Kids, we are starting into geometry, and we're going to be getting into proofs this chapter. We've got to do some introductory stuff first, okay? So geometry follows this deductive structure, which is where, always have that happen, where conclusions are justified by means of previously assumed or proved statements. In other words, it's a very top-down approach. We're going to be working with what we know. And how do we know it? Well, we know it because we're told it. We're given information. We're going to be assuming maybe some basic things from a diagram, not much. And then we're going to have a toolbox of like reasons, which are called like theorems and definitions, that we're going to use to justify our steps. There are other methods of logic, indirect proof, stuff like that. We'll be talking about some of them later on, but 98% of what we do is going to be deductive, top down, and you'll see where it goes here. We're just getting started here. So a theorem. Is like a statement that can be proved, okay? A theorem can be proved. And a postulate is generally accepted. It's generally accepted, unproven assumption. So there are some things that mathematicians have decided to just accept, is what it comes down to, okay? The foundation of what we're going to be doing with deductive structure is we're going to be using the conditional statements. The hypothesis is the if part, and the conclusion is the then part. Something like if today is Tuesday, then tomorrow is Wednesday, right? So, we're going to be writing a lot of reasons in a conditional phrase. Now down here, you're asked to rewrite all of these statements in conditional form. It's really a little bit too easy. I'll just do one of them. All leap years have 366 days. We could rewrite that like if a year is a leap year, then it has 366 days. Okay? So you just get the idea. You can rewrite a lot of this stuff. Now, mathematicians are inherently kind of lazy. They don't want to write any more than they have to. So instead of saying like if this then that, or if P then Q, they'll often use these symbols. So this P then Q, that means if P then Q. This double arrow is the then, okay? There's another, you'll see this symbol here, this little squiddly, that stands for negation or not. It just means the opposite. Sometimes you'll just see a minus sign, okay? It just means the opposite. Now, if I have a statement, every statement has a converse, and what that means is you flip around the Q and the P. So if our original statement is if P then Q, our converse would be if Q then P. Every statement has an inverse too. So if we take the original statement, the inverse would be to not both of the originals. So instead of if P then Q, it would be if not P, then not Q. Okay? And then the contrapositive is a double whammy. We're going to take the original statement, we're going to flip it around and not them both. So this would be if not Q, then not P. All right? Now let's look at an example here. Here's the original statement. If ABC is a right triangle with right angle C, then A squared plus B squared equals C squared. You guys are probably familiar with that, better known as Pythagorean theorem. Now, we're not going to worry about the truthiness, the truthfulness of the following three statements, but every statement has a converse. So the converse of this one would be if A squared plus B squared equals C squared, then triangle ABC is a right triangle. Again, whether or not that's a true statement, turns out it is true, but that's the converse. Okay? The inverse, of course, would be if ABC is not right triangle with right angle C, then A squared plus B squared does not equal C squared. And again, regardless of whether that's true, that's still the inverse. Okay? Turns out that's true. That's just coincidence, though. And then finally, the contrapositive, if A squared plus B squared does not equal C squared, then triangle ABC is not a right triangle with right angle C. Okay? All right. So all of these statements have a, if you have a statement, you have a converse, inverse, and a contrapositive. Okay. Now let's look at one more together here. If x equals 2, then x squared equals 4. So the converse would be what? If x squared, got some disappearing ink. If x squared equals 4, then x equals 2. We'll discuss the truth factor afterwards. The inverse would be what? If x does not equal 2, then x squared does not equal 4. And the contrapositive would be if x squared does not equal 4, then x does not equal 2. So let's go ahead and, first of all, the original statement, if x equals 2, then x squared equals 4, that's certainly true. Converse, if x squared equals 4, then x equals 2. And I hope you realize that that is false, because if x squared equals 4, x could be 2 or negative 2, so that was false. Inverse, if x does not equal 2, then x squared does not equal 4. Well, that's not true, because if x is not equal to 2, it could be negative 2. X squared would be 4, so that doesn't work. Contrapositive, if x squared is not 4, then x is not 2. That ends up being true. So here we had, not everything was true, whereas the previous one, everything was. It turns out, folks, and this is huge, this is what we have to take from this. The contrapositive is logically equivalent to the original statement. Okay? In other words, the contrapositive is saying the exact same thing as the original statement. So if the original statement is true, the contrapositive would be true. The contrapositive is saying the exact same thing. By flipping it around and nodding both of them, you're essentially kind of canceling everything out and you're back to where you started, if that makes sense. But that's what I need you to be aware of. The contrapositive is the same exact thing as the original statement. The converse and inverse are not. Converse and inverse are not. All right. Sometimes they might be true, sometimes they're not. That's not really critical. You should be able to write down the converse or the inverse, but they're not logically equivalent. I'm not going to do number 3. I think you kind of get the idea of this. Now here, these things can get really weird. Let's go down to the bottom first, not the words. Okay, we're going to do a couple of these together. Well, I'm in a video, so what we want to do here, so this D is 2 separate problems. You see the line here separating the two. So we have the top and then the bottom problem. And what we want to do, what we're tasked with, is we want to condense these 4 statements into just one thing. And I'm just going to walk through this one, and we want to condense this to if something, then something, and that kind of sums it all up. So what you do is you look for an endpoint. You look for letters that are mentioned just one time. And you see here how we have A twice, we have B twice, we have C, some kind of form of C twice. I see D only once, I see F only once. So watch this. Seeing that D is on the left, I'm going to start with that. So if D, then not C. If not C, then A. If A, then B. If B, then F. So this can all be condensed to if D, then F, right? Because again, D then not C then A then B, B then F. It's just a chain of reasoning here. So we could really condense that all to just if D, then F, right? The next one's a little bit trickier. So if you look, you're looking for your endpoints. You see that M and P are only mentioned once. But you see, if I start with P, which is on the left, P then not Q, I don't have a not Q over here. So I'm a little bit unsure. But then you have to go back to what we just talked about before. We can rewrite this first one as the contrapositive. Remember, the contrapositive is logically equivalent. So this top thing is really the same thing as if not Q, then R. So let's just change it to that. Now watch. If P, then not Q. If not Q, then R. If R, then M. So this all comes down to what? If P, then M. Okay? Sometimes I've had students write down if not M, then not P. And remember, that would be correct as well, because if not M, then not P would be logically equivalent to if P, then M, because it's the contrapositive. All right, now this word stuff, I don't want you to get too hung up on this, but it can be tricky. We're doing the same thing here, but usually I would find it easier to go ahead and translate these sentences to using just simples. If gremlins grow grapes, we'll just call that G, then elves eat earthworms. If G, then E. If trolls don't tell tales, so if not T, then wizards weave willows, and then W. If trolls tell tales, that would be T, right? Then elves don't eat earthworms, so that would be not E. So find your starting point. It looks like you see G and W are mentioned just one time. So G is on the left, so let's go with that. If G, then E, we would think of this as if E, then not T. If not T, then W. So by taking the contrapositive of this third one, we can condense this to if G, then W. Okay? These can be weird. There's no doubt about that. Babies, if babies, then illogical. Nobody's despised who can manage a crocodile. So you got to be careful with this one. Nobody is despised who can manage a crocodile. So that's really, we're really starting with this crocodile. Crocodile, then nobody despised. It's kind of written backwards. Okay. Illogical persons are despised. So C is mentioned once. I'm going to start with that. If C, then not D. Remember, this would be what? If not D, then not I. And then this would be if not I, then not B. So this would be condensed to if C, then not B. Tricky, I know. And the third one's tough too. If you want to play around with it, you can check my answers on the solution sheet that'll be posted later on. Okay, I'm not going to talk about that one right here though. But don't bang your head against the wall too long about this. Okay.